Okay, so on these solving questions, you've basically got two different types of things that you're going to deal with. You're either going to be dealing with like a quadratic situation where you factor like a quadratic, or you're dealing with common factors and you're factoring the common factors. In this case, I've got a tangent squared, a tangent, and then constants, which means it's going to be a quadratic. So tangent squared, I'm going to add the 2 tan over, and then I'm going to subtract 4 from the 5, which gives me 1, so plus 1 equals 0. So get everything on the same side and set it equal to 0. And then factor like a quadratic. What are the factors of 1 that add up to 2? And that's 1 and 1. So that's tangent of theta plus 1 times tangent of theta plus 1, which is basically just solving one of those. When does tangent of theta plus 1 equal 0, or when does tangent of theta equal negative 1? So using my unit circle, which I've got somewhere, tangent is sine over cosine. So when you have y over x, the only way you're going to get a 1 is if they're the same thing. In this case, tangent of theta would be 1. I need negative 1. So I'm thinking, right? I need, when does tangent equal negative 1? Yep. So I need 3 pi over 4 because I've got something divided by negative itself, and then not 5 pi over 4 because they're both negative, but 7 pi over 4 where I've got a negative divided by a positive. So my answers are 3 pi over 4 and just kidding, 7 pi over 4. All right. Now, if I had asked for all answers, then these are only pi apart. So I could have said, if it said all answers or all solutions, then I would have said 3 pi over 4 plus pi n. Okay, because every pi would be another answer. All right. Number 2 says 2 tangent plus secant squared theta equals 0. All right, so in this case, I have two different functions. Secant squared I can actually replace, so I know my Pythagorean are sine squared plus cosine squared equals 1. Divide by cosine squared, I get tangent squared plus 1 equals secant squared, and divide by sine squared, and I get 1 plus cotangent squared equals cosecant squared. So they're there if I need them. In this case, tangent I can't replace in terms of secant because it's to the first power. Well, actually I can, but it wouldn't help me in this case. I can replace secant squared though. Secant squared is tangent squared plus 1. So negative 2 tangent plus tangent squared theta plus 1 equals 0. All right. I'm going to write them in order. Tangent squared theta minus 2 tangent theta plus 1 equals 0, which is basically the same as the last problem, only it's a negative on the interior, which means my two factors are tangent of theta minus 1. Which means I'm really just solving when does tangent of theta minus 1 equals 0, or when does tangent of theta equal 1, and that is at the other quarter pies, which is pi over 4 and 5 pi over 4. All right, number 3. Okay, I've got cosecant secant equals 2 square root of 2 cosecant. What you don't want to do is, now that being said, what I'm about to say is actually not going to change the answer in this case because of the nature of what it is. You do not want to divide out a trig function. Okay, you lose the possibility of an answer, and I'll explain in a second. So cosecant of theta is secant of theta minus the square root of 2 secant of theta. Both terms have a secant in them, which means I can factor out a secant of theta, leaving me with cosecant theta minus the square root of 2 equals 0. Okay? So technically, zero product property, I've got two different equations I'm solving. When does secant of theta equal 0? And when does cosecant of theta minus the square root of 2 equal 0? Or when does cosecant of theta equal the square root of 2? Because I can add that over. All right, now this right here, again, like I said, in this case, oh, I changed the whole problem. I was going to say, wait, what's wrong? This is cosecant. Just kidding. which means the common factor is cosecant, and this is secant. No bad. Okay. Cosecant does not ever equal 0, okay? Because that's implying that sine of theta equals its reciprocal, 1 over 0. And sine's never undefined. Sine is a continuous function for all real numbers. So there is no solution for that little part. But what if the common factor had been cosine, not cosecant, right? Cosine equaling 0 has multiple answers. So you cannot just divide out a common factor. You need to make sure that you factor it out and solve its problem as well. So for this, there's no solution. However, for this, secant equaling the square root of 2 is the same thing as cosine equaling 1 over the square root of 2, which is the square root of 2 over 2. So when does cosine equal the square root of 2 over 2? Cosine is the square root of 2 over 2 at pi over 4. Not at 3 pi over 4 because it's negative. Not at 5 pi over 4 because it's negative, but at 7 pi over 4 as well. So my answers are pi over 4 and 7 pi over 4. All right. Number 4. All right, I've got cosine squared, sine, and sine squared. So I'm going to get everything on the same side first. Negative cosine squared theta minus sine theta plus sine squared theta. And then I'm going to think about this. Whichever term is linear is the one that I have to make sure that the rest are in terms of. I can't replace sine in terms of cosine, but I can replace cosine squared in terms of sine. So I know that sine squared plus cosine squared equals 1. So if I were to subtract cosine squared over here and then subtract the 1 over there, then I could say negative cosine squared is equivalent to sine squared minus 1. Yeah? Or think of it like this. I could just put a negative in front of everything and then add the sine squared over. Negative cosine squared equals sine squared minus 1. So negative cosine squared equals sine squared minus 1 minus sine of theta plus sine squared theta equals 0. Oh, sorry. That's all wonky. Okay. Now I'm going to combine like terms. Sine squared plus sine squared is 2 sine squared minus sine minus 1 equals 0. Okay, so I need a factor. I need the factors of negative 2 that add up to negative 1, and that's negative 2 and 1. So I've got sine of theta minus 2 and sine of theta plus 1. And then don't forget to divide. So divide by 2. So I'm really solving when does sine of theta minus 1 equal 0, and when does sine of theta plus 1/2 equal 0. So you could say 2 sine theta plus 1, but might as well just keep thinking about this. So when does sine of theta equal 1, and when does sine of theta equal negative 1/2? So if you look at your unit circle, sine of theta equals 1. I'm not going to keep flashing over here because you can look at your own unit circle. Pi over 2. And sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. And there we go. All right. Number 5 is another factoring problem. So, well, actually, the only trig function I have is cotangent, so I'm only going to move the cotangent over here. If I subtract 2 cotangent squared, I'm just left with cotangent squared equals 1. Take the square root. Cotangent of theta equals plus and minus 1. If you take the square root, you got to do 2 answers, right? Cotangent equals plus and minus 1 is the same thing as tangent equaling plus and minus 1. Because the reciprocal of 1 is 1. Cotangent is cosine over sine, so the only way you're going to get 1 is when you divide something by itself. So this divided by this is 1, this divided by this is negative 1, this divided by this is 1, this divided by this is negative 1, so all the quarters. Which means my answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now these are each a half pi away from each other, so in fact you could say pi over 4 plus pi over 2n. That being said, that's only if I asked you for all solutions. If I just ask you for from 0 to 2 pi, then you're done right here. All right, number 6. So on number 6, you've got square root of 2 tangent plus 2 tangent cosine equals 0. I see that they both have a tangent in them, so I'm going to factor out the common factor. Tangent of theta equals the square root of 2 minus 2 cosine of theta equals 0. So I'm asking, when does tangent equal 0? And when does the square root of 2 minus 2 cosine of theta equal 0? Or, if you subtract the square root of 2 and divide by negative 2, when does cosine of theta equal the square root of 2 over 2? Okay. Tangent equaling 0, tangent is sine over cosine, right? So the only way that you're going to get 0 is if you have 0 on top, and when sine is 0, cosine is either 1 or negative 1. So basically you're just looking for when does sine equal 0. And sine equals 0 on the x-axis at 0 and at pi. Terrible data. And then when does cosine equal the square root of 2 over 2? That's at pi over 4 and 7 pi over 4. All right. Number 7. Number 7 is interesting because it's got secant, it's got tangent. Neither one of those are the same function, nor are they squared, meaning I can replace them. But what I can do is think about this. Secant is 1 over cosine. Tangent is sine over cosine. They both have something over cosine, right? Meaning tangent, which is sine over cosine, is equivalent to saying sine times secant. Because when I think about factoring out common factors, like as options, I got to think, well, does this one include secant? Does this one include something else? Could I have written this as 1 over cosine and sine over cosine and factored out a 1 over cosine? Sure. And that would have been secant. So anyway, I'm really dealing with the square root of 3 secant of theta minus 2 sine theta secant theta. So, oh, sorry, I'm going to turn it so I can turn it. All right, I'm going to go ahead and put the equal 0 on this side. I'm going to factor out secant. So secant of theta times the square root of 3 minus 2 sine theta. And so I'm solving when does secant equal 0 and when does the square root of 3 minus 2 sine theta equal 0. Or when does sine of theta equal, if I subtract the square root of 3 and divide by negative 2, I get positive square root of 3 over 2. Secant of theta never does equal 0, so that's no solution. And sine equals the square root of 3 over 2 at pi over 3 and at 2 pi over 3. So those are the only two answers to this problem. Number 8, we want to get everything on the same side. So I'm going to subtract my 4 cotangent over, which leaves me with cosecant theta, and then minus 2 cotangent theta. And very similar to the last problem we did, cotangent is cosine over sine, which means I can rewrite this as cosine times dividing by sine, same as multiplying by cosecant of theta, which equals 0. Okay, I'm going to factor out a cosecant, and I'm left with 1 minus 2 cosine. So I'm asking, when does cosecant of theta equal 0, and when does, and I'm going to go ahead and just move this along. Subtract 1 divided by negative 2, and I get positive 1/2. So cosecant of theta never does equal 0, so that's no solution. Just as a reminder, cosecant is the reciprocal of sine, so if sine does this, cosecant does this. Cosecant never hits the x-axis, that's why it never equals 0. Okay. Cosine equals 1/2 at pi over 3 and 5 pi over 3. So those are my only answers. Okay. Number 9. On number 9, I've got cotangent squared, and a constant, so that means a quadratic to me, so I'm going to add the cotangent squared over. So cotangent squared minus 2 cotangent plus 1 equals 0. Factors of 1 that add up to -2 are -1 and -1. So cotangent of theta minus 1 squared, if you will. Cotangent of theta minus 1 times cotangent of theta minus 1. The square doesn't matter. You square it both sides, it's still 0. So when does cotangent of theta minus 1 equal 0? Or when does cotangent of theta equal 1? Cotangent of theta is the same, equaling 1 is the same thing as tangent of theta equaling the reciprocal of 1, which is just 1 over 1, which is 1. So tangent of theta equals 1 at pi over 4 and at 5 pi over 4, where square root of 2 over 2 over square root of 2 over 2, and then the two negatives cancel each other out. All right, number 10. On number 10, we've got a sign in both terms, so I'm going to factor out sign. So sine of theta equals, or times tangent of theta minus the square root of 3 equals 0. So I've got when does sine of theta equal 0 and when does tangent of theta equal the square root of 3. So if I set that tangent theta minus square root of 3 equal to 0, I can just add the square root of 3 over. Sine equals 0 on the x-axis, which is at 0 and pi. We don't include 2 pi because remember the answers are only from 0 to 2 pi not included. And tangent equals the square root of 3 when you've got, so tangent is sine over cosine, right? So 1 divided by the square root of 3, we never include the 2's because they always simplify out. 1 divided by the square root of 3 is square root of 3 over 3. However, square root of 3 over 1 is just square root of 3. So square root of 3 over 1, so that's pi over 3. So we're looking for square root of 3 and 1. Square root of 3 and 1, but one of them is negative. Square root of 3 and 1, both negative, simplifies to a positive, so 4 pi over 3. And then this one, again, one of them is negative. So my answers are 0 pi, pi over 3, and 4 pi over 3. A lot of times if this is multiple choice, you would see them in order, like this. But you do not have to put it that way. You do have to be able to recognize it, but there you go. Okay. On number 11, I said that you can do these using a calculator. So I would expect you to, first off, if I'm asking you to find the answers from 0 to 2 pi, you need to make sure you're in radian mode. So I'm in radian. Y equals, I'm going to graph, I'm going to show you a couple different ways to do this, okay? So one way to do it is to graph each side. So if I graph negative sine of x squared, by squaring the parentheses, you're squaring sine, and negative sine of 2x squared, then I only want to find the answers from 0 to 2 pi. And you never need to go very high or low on these. In fact, I think we can go, they're both negative, so I'm going to go, there we go. Okay, so I'm supposed to find all the intersections when these two functions equal each other. So I'm thinking I've got when they start, because, I mean, at 0, they're both 0. Sine of 0 is 0, right? So I've got an answer here, I've got another answer here, here, and then another answer here, which is pi, another answer here and here, and then another answer 2 pi, although we're not going to include 2 pi, right? Now, how do I know that's pi? Because this is a symmetrical function, and the window is from 0 to 2 pi. If I make my steps pi divided by 2, then you can see better that they intersect at pi, because this is 1/2 pi, pi, 3/2 pi, and 2 pi. Okay? As far as finding their answers, I know the first one's 0, and if you want to go to the table and look, you can tell. At 0, they're both 0, right? I can also prove it as far as them both being the same at pi, because you can't find the intersection right there. You can say alpha y equals y1 at pi, and you get 0, and then if you do alpha y equals and do y2 at pi, you get the same answer as well. So 2 of my answers are 0 and pi. As far as the others go, if I'm finding the intersections, I go second calculate number 5. Whichever intersection I'm closest to and I press enter, 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 that's the one it's going to find. So if I press enter, 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 it'll find that first one. So I could say my answers are theta equals 0. The next one is 1.047. 3 decimals is the thousandth place, is fine. Second, calculate 0. Just kidding. Second, calculate intersection. Oh my gosh. Second, calculate the intersection. So go over here, enter, enter, enter. As long as I'm closer to that one, we'll find that one. 2.094. Okay. Second, calculate intersection. Enter, enter, enter. 4.11, or sorry, 4.189. Okay. And then one more. Second, calculate intersect. And you get 5.2. Ooh, just kidding. I forgot pi. I'm just going to put pi. Although, that's great. 5.236. Okay. So the thing about intersections is that when they just meet at the same time, it's kind of hard to. Let me make sure it doesn't find it before I say anything. It's like they don't cross, but yeah, no, it doesn't like it. Okay. Okay, which is kind of why I prefer this. I prefer to get everything on the same side and think about, like, so if I add this over, then I'm just solving for when it equals 0, right? So if I add sine of 2x squared, and I look at my graph now, I'm only going to go negative 1, 1. Okay. Then I know that I have, again, the number of times it equals 0 is the same number of times that these two functions equal each other. 1, 2, 3, 4, 5, 6, 7, but the 7th is 2 pi. So 1, 2, 3, 4, 5, 6. Okay? I'm going to prove to you right quick that they're the same. If I do the 0, okay. I know this is pi over 2. So I know pi over 4 is somewhere in here. I'm just going to type in second pi divided by 4 is my left bound. So I'm going to go to the left of pi over 4, and then I'm just going to use pi over 2. .047, yeah? Now, if I go back to my window, because most of you kept your scale on 1, then it's a little bit easier to find your zeros. So that's 1, so you know it's around 1. This is around 2. This is around 3 point something, pi. 4, 5, and 6, right? So if I want to find this one, then I can go second calculate number 2, 0. It's around 2. I know 2 is the left of it, so if I press enter, or 2, enter, and then like 2.5, enter. So it's somewhere between 2 and 2.5, and press enter through guess, and 2.094, which is one of the answers we have. Okay? All right. Number 12. Number 12 is these two. Like I said, I prefer getting everything on the same side and finding when it equals 0. So I am going to just subtract the 3 over. So negative 4 sine of x divided by 2 plus cosine of x minus 3. And, yeah, 0 to 2, okay, graph. So the reason why I like this is because I don't have to know how high or how low to go. And in fact, because of this, if I go, let's say 5. Heck, I don't even know where they are. Okay. So if I go, okay, they're all negative. Just kidding. Oh, I had a minus 3 down. So I go negative 7 and 2. So I can see that my function is way down here, right? My whole point though is I subtracted 3 and I'm now testing when does this equal 0. And you can tell from 0 to 2 pi, this never hits the x-axis, so that means there is no solution to this problem. If you were to graph 3 and graph this side, you would see that they never equal each other, so no solution. All right, I did say you could find the answers just from 0 to pi on this one. I guess I didn't specify whether or not to include pi. But, oh crap, I gotta sign back in. Give me a second. I guess I don't really care either way. The reason being there are a ton of answers. So if you just graph this and you want to find the zeros, you've got a lot of them. I'm going to leave that up to you guys to find those answers. That's the part. All right. This says find all solutions to the equation in radians. Okay. Okay. So I want to get cosecant alone, which means I need to divide by the -4. So cosecant of theta equals, when you divide by -4, 2 divided by -4 is -1/2, so the square root of 3, negative square root of 3 over 2. Okay, so when I think about that, as far as square root of 3 over 2 goes, that's a sine or a cosine value. It's not a cosecant. Cosecant can be the reciprocal of that, but it can't be that, meaning there's no solution. All right, because that's basically asking me when does sine equal -2 over the square root of 3, and that's just, it doesn't happen on the unit circle, so it's not, no solution. All right, on number 16, I need to solve for when cosine of theta equals, well, let me add 3 and divide by -8, so -1/2. So when does cosine equal -1/2? Well, cosine equals -1/2. Cosine is the x value. -1/2 at 2 pi over 3. And the next time it equals -1/2 is at 4 pi over 3. Those are not a pi away or a half pi away. They are a, a radian amount away. But as long as they're not 180 degrees away from each other, then I just go ahead and say plus 2 pi n for each of them. And then 4 pi over 3. Where n is nomen of the integers. Okay. Okay, solve each equation for theta between 0 and 2 pi. So, cosecant of theta divided by 2 equals 2 square root of 3 over 3. Well, okay, 2 square root of 3 over 3 is equivalent to 2 divided by the square root of 3. That's just the rationalized form of this. So when I'm talking about cosecant equaling this, I'm really talking about sine equaling square root of 3 over 2. So when I look at this, it's like, when does sine equal the square root of 3 over 2? Sine is the square root of 3 over 2. Sine's a y value at pi over 3. At sine equals square root of 3 over 2 at 2 pi over 3. It's negative here and negative there. Yeah? And then, okay, this is the type of problem where you might have to, do more rotations to find your answers, but the thing about it is that this is a horizontal stretch. See, it's by a factor of 2 because it's 1/2 in the interior, opposite in the interior, which means you're not going to get more answers. In fact, you might get less answers. So what you do is you set, it's cosecant of what would give me that, and so I know cosecant of pi over 3 would give me that, but the point is to solve for the theta that makes that true, and theta is being divided by 2. So I multiply by 2, and theta is actually 2 pi over 3. Okay? in this case, theta over 2 has to equal 2 pi over 3, because again, 2 pi over, cosecant of 2 pi over 3 would give me that. So, but the point is to solve for the angle divided by 2 that makes that true. So theta equals multiply by 2, 4 pi over 3. And that is still within my window of 0 to 2 pi, so we're good. All right. On the next one, you've got a shift to the left. So, okay, we're going to talk about, or we're going to find all the answers, all the times that cosine equals -1, right? So cosine equals -1 at pi, yeah? It doesn't equal at -1 again until 3 pi. So remember, every answer, if you just add 2 pi to it, then you get the next rotation. I don't think that's going to be an issue, though, or going to be an answer. So if I set that equal to theta plus 3 pi over 4, and I subtract 3 pi over 4, then this becomes over 1, and if you want to find a common denominator, then you multiply by 4. So 4/4 minus 3/4 is 1/4, so my answer right here is 1/4 pi. And then over here, just to see if you would get an answer between 0 and 2 pi, if you subtract 3 pi over 4. So over 1, you multiply by 4, you get 12. 12/4 minus 3/4 is 9/4, and that is outside of my window. So my only answer is pi over 4. All right. Number 19. Number 19 is cotangent of -2 theta plus pi over 6 equals the square root of 3 over 3. So basically, when does cotangent equal the square root of 3 over 3? But we do need to talk about this. This is a shift to the left, pi over 6. It is a, well, actually, it's different than that because of the horizontal compression. Okay, it is a horizontal compression, which means we could have more answers, but it's also a reflection over the y, which means we could have answers going left. In fact, we probably will. So this is going to be a little bit different. What I'm going to do is I'm going to find all my answers, and not only am I going to add 2 pi to them, I'm going to subtract 2 pi to them so you can see which ones are actually going to give me my answers. Okay, so when does cotangent equal square root of 3 over 3? Cotangent is cosine over sine. So cosine over sine, square root of 3 over 1 is just square root of 3. But right here, 1 over the square root of 3 is square root of 3 over 3. So pi over 3 is one of my answers. With my pen, all right. Okay. So I'm looking for 1 and the square root of 3. That's negative, so it doesn't work. 1 and the square root of 3, they're both negative, so when I do cotangent, which is -1 divided by negative square root of 3, I'll get positive square root of 3 over 3. So my next answer is 4 pi over 3. So when we work these problems in the homework, I never gave you a reflection over the y, so you knew that if it was a horizontal compression, then that means you might have more answers, so we added rotations. But in this case, it goes negative, so I think I'm gonna add 2 pi, but I'm also gonna go backwards and I'm gonna subtract 2 pi. Okay, and I'm gonna show you what happens. So if we add 2 pi, then we get 2 pi is the same thing as 6 pi over 3, right? So when we're adding 2 pi, it's adding 6/3 pi. So that becomes 7 pi over 3, and this becomes let's see, 6, so 10 pi over 3. And in fact, I could keep adding if I thought that I might get more answers. We'll explore that in a second. But I'm also going to subtract 2 pi. So 1 minus 6 is -5. Meaning, if this is an answer at pi over 3, then it makes sense that if I go backwards 2 pi, this is also going to be an answer again, right? We're merely talking about taking a wave and just going backwards. Because see, the cotangent wave does this, right? Well, it stands to reason that if you're trying to know when does it equal this number, it could be here, it could be here, it could be here, it could be here, and this is just rotations, right? So, all right. I'm going to subtract 6 pi as well from here, so 4 minus 6 is negative 2. Yeah, negative 2 pi over 3. Okay, and if I wanted to go backwards some more to see if I get some answers, I think I might. If I subtract 2 pi again, negative 5 minus 6 is negative 11, and negative 2 minus 6 is negative 8. So the idea is any of these rotations, these are all the same like intersections, you know what I mean? These are all intersections. It was just a matter of which answers are going to give me an answer between 0 and 2 pi, right? So what you have to do is set each of these equal to this right here and solve. So I'm going to start with, I'm going to go ahead and line them up in order. So I've got negative 11 pi over 3, negative 8 pi over 3, negative 5 pi over 3, negative 2 pi over 3, pi over 3, 4 pi over 3, 7 pi over 3, and 10 pi over 3. So these are all the answers that I've identified as just rotations of the answers I know that cotangent of these angles, so forget all that crap in the interior, equals square root of 3 over 3, right? So I'm going to add, or sorry, set them each equal to negative 2 theta plus pi over 6. Negative 2 theta plus pi over 6. Negative 2 theta plus pi over 6. I probably won't need those, so I'm not going to keep going. Okay, so the first step is always going to be subtract pi over 6, right? The thing about it is whenever you combine that, or when you add fractions, you've got to have common denominators, so multiply by 2. So if I multiply this by 2 on top and bottom, then I've got negative 22 pi over 6. So negative 22 minus 1 is negative 23 pi over 6. Negative 12 pi over, this, oh, yeah, sorry. That equals negative 2 theta. Let's see. We're still not there. Okay, and then if I were to divide by a negative 2 or multiply by negative 1/2, then theta equals, if I multiply by negative 1/2, the negatives cancel each other out, and I'm left with 23 pi over 12. Well, that is my first answer because I need answers between 0 and 2 pi, and 24 pi over 12 is 2 pi. Meaning I went back far just enough. So if I had only gone back one rotation of each answer, so this is one rotation of that one, this is one rotation of that one, right? Then I would have found that these answers were not, like I didn't account for enough. I would probably need to do one more rotation, okay? So I'm pretty sure with 23 pi over 12 that another rotation backwards would not have gotten me any answers. But in this case, I didn't get that. So interesting. Okay, we're going to subtract pi over 6. Again, multiply by 2. So this becomes negative 16 pi. Negative 16 minus 1 is negative 17. So I've got negative 2 theta equals negative 17 pi over 6. Multiply by negative 1/2. And you're left with theta equals 17 pi over 12. Which is an answer. It's between 0 and 2 pi. Or I guess I should say between 0 and 2 pi, or between 0 and 24 pi over 12. All right? So I'm going to subtract pi over 6, multiply by 2, and you get negative 2 theta equals, it's negative 10. So negative 10 pi minus 11 is negative, or sorry, minus 1 is negative 11 pi over 6. Multiply by negative 1/2, and you get theta equals 11 pi over 12. We're going to subtract pi over 6. multiply by 2 on top and bottom, get a common denominator that becomes negative 4 pi. So negative 4 pi minus 1 pi is negative 5 pi. So negative 2 theta equals negative 5 pi over 6. Multiply by negative 1/2, I'm left with 5 pi over 12. Subtract pi over 6. So we're getting into that original set between 0 and 2 pi. So eventually we're going to catch up to 0 or 2 pi. Yeah, 0, I guess we're going to say, because we're kind of going backwards. So you multiply by 2, and 2 pi minus pi is pi. So negative 2 theta equals pi over 6. Multiply by negative 1/2. And you can see that here you get theta equals negative pi over 12, and that is outside the window. So these are my 4 answers. That one is kind of interesting. When you reflect over the y-axis, instead of adding rotations, you need to subtract rotation. Okay, because you're reflecting over the y. Okay, I'm gonna stop this video and start the next one in a minute.